First question we have in mind is, what is design parameter? Design parameter is a concept to assign a variable to a size or shape entity instead of a single fixed value. This variable can change to any value that we give later. In this, in order to change shape or size, we just have to change the value given to the variable, and the variable will change the entity wherever it appears. So, we need a reference variable which will define a model dimension or feature. Such a design parameter will have a name and a value attached to it. When you enter this name into a dimension dialog, the dimension is set to the corresponding value of the design parameter. We can also form expressions using design parameters. The most important things is the design parameter allows you to change the feature values from outside 3D CAD. There are three types of design parameters: angle, length and generic. We will see these in detail in the slides to come. Well, till now it was all about CAD, sketches, CAD operations. You must be wondering, till when will this go on? What should I do with all these CAD features? Finally, you need to know how to get started with CFD, and for that you need CFD domain. How to build a CFD domain? The wait is over. Now we will see how to build a CFD domain from a CAD model which is either created in *CCM Plus or imported into *CCM. How do we build a CFD domain? For creating a CFD domain, we need volume. We need to somehow extract this volume. 3D CAD tool can automatically extract volume. This volume can be space surrounding a model or volume of space inside a model. We can use this extracted volume to create a new separate body as well, which can also act as a volume for building CFD domain. This volume or geometry will finally represent a fluid domain or CFD domain. It is inside this volume that *CCM Plus will solve the CFD equations. What is this volume extract and what does it do exactly? When you extract a volume, 3D CAD finds a continuous surface within or around a solid model and uses it to create a new body. This body is extended up to arbitrary limits, which are determined by whether the extraction is internal or external. What is internal volume extraction? This basically means extracting volume that is inside some enclosed surfaces. The internal volume extraction tool caps all inflow and outflow openings in the model and fills the void created with new solid body. The rule for this is that the geometry used for extracting its internal volume must be closed. That is, it should not have any holes or gaps apart from any inlets and outlets. The external volume extraction works in exact opposite manner. In this, a bounding body is placed around a model. The volume created between the outer surface of the model geometry and this bounding body is used as volume for CFD. We can control the size of the CFD domain by controlling the extent of the bounding body. In this process, any holes, hollows, and crevices in the model geometry are filled with the new solid body in the same way that they are filled by a surrounding volume of gas or liquid.